Hello everyone, I am Ananya Kumari of MTech IT 5th semester, and today in this video I will be solving the end semester question paper of data science. So let's begin. So the first question is, distinguish between hypothesis driven and data driven paradigms in data science and provide example of each. So hypothesis driven means we start with a theory or a hypothesis about the world, then connect the data and run tests to confirm the result and hypothesis. We already have a problem, theory or statement, verifying which we need data, so we collect data, perform certain steps for the experiment to check if it is true or not. While data driven, we have data available and we check for underlying pattern, and then we generate hypothesis, build predictive models with a strong prior theory. The goal of hypothesis driven is test causality or specific scientific claims, already a statement already being claimed. And for data driven, the goal is discover patterns, build accurate predictions, or generate new hypotheses. In hypothesis driven, we have our focus inclined to only one or two statements. But in data driven, there can be a number of problems that we can solve with the given data. Methods, so talking about method, hypothesis driven includes experimenting, control trials, A B testing, statistical hypothesis tests. Data driven includes exploratory data analysis, feature engineering, machine learning, unsupervised learning, and model selection. All these methods leads to the efficient use of available data. When to use? So hypothesis driven is used when you have a prior domain knowledge or theory to validate, and data driven when a large data set exists but theory is incomplete. We already have a data set, theory is incomplete, we don't have a statement ourselves. Example, drug X reduces blood pressure more than placebo. So we already have a statement. Now we will collect data to verify if it is true or not, and use clinic stream logs to cluster user and discover unexpected customer segments, then build recommended system. So suppose let's take a simpler example. Suppose we have data of 1 million patients and we are analyzing according to their diet what are their blood pressure and sugars. So we can develop a system, or we can develop theories like if if a person eats after 8 p.m., then 80% of the person suffers from diabetes. So these kinds of problem can be solved with data driven. Moving towards the next question, next part of this question, which is question A B, differentiate between structured, unstructured, qualitative, quantitative, categorical data with suitable real world example. So structured data is organized in tables with a fixed schema, fixed data type, what kind of format gonna store in the database. uh, for example, relational database, customer table, CSV, sales record. On these, query can be easily performed, or fixed format strings. These are either numeric or fixed format strings. In unstructured data, we don't have a predefined schema, text, image, or audio or video. It can be audio or video or images. For example, customer support emails, product images, call recordings. It requires NLP, computer vision, to extract features. Otherwise, we won't be able to execute query or identify patterns within it. Quantitative data means numerical values that represent count or measurement. There are two types, continuous and discrete. Continuous means we can have a number, and discrete means we can have, we don't have values in range. We are bound to specific number of specific numbers. Categorical means data can be labels or categories, non-numeric. For example, we have a column named as place. So in that column, there won't be numeric data. There will be categorical data such as Indore, Patna, Delhi, Mumbai, Bangalore, Canada. And it can be nominal, it can be ordinal. For example, payment method, satisfaction. Structured and unstructured refers to formal schema, if it has a formal schema or not. While quantitative versus categorical refers to variable type. A structured table can contain both quantitative and categorical column, and unstructured text can be transformed into structured features. Moving towards the next question, which is write an algorithm that uses Bayes' theorem for decision making. So, first of all, why do we use Bayes' theorem? We use Bayes' theorem if in a table we have a column, and for a specific row we have other informations, and on the basis of that information or features, we predict in which category will that specific row a person will fall into for a column having a missing value. So the algorithm is this way: we start and we identify the possible classes for decision making, then we collect the prior probability for each class. Suppose if we have to categorize a person into short, tall, or medium category according to their heights, we will have to first calculate the probability of it being in that class. And then we calculate the likelihood value of evidence E for each class. For this, we calculate E with respect to C1 using Bayes' theorem. Then we compute the marginal probability of evidence by multiplying the likelihood value of evidence for each class into the probability of each class, and keep summing the product for each class. In the next step, for each class we compute the posterior probability using Bayes' theorem, which is calculated this way: probability of class I with respect to E is equal to probability of E with respect to class I into probability of class I divided by probability of evidence. Now we compare all the posterior probabilities, and which one has the maximum value will be the chosen category to be filled in place of the missing value. This is all to be done in Bayes' theorem. Moving towards the next question, we have write any suitable algorithm for association rule mining that can build on association rules. So here we just start, then we input transactional database, then we set the minimum support and confidence threshold. All these values are set in accordance with the system it works for. Then we generate all the frequent items from the database using the a priori property. If item set is frequent, all of its subsets are also frequent. For each frequent item set, generate all possible non-empty subsets. After that, for each subset S of the frequent item F, we calculate the confidence by dividing the support of frequent item set divided by the support of subset. If confidence is greater than equal to minimum confidence, then form the rule S tends to be F minus S. Then we store and print all the association rule that satisfies the confidence threshold. Then we just stop. This is all to be done for this. Moving towards the next question, we have Compute mean, mode, and median standard deviation for all given small database. Explain when each method is appropriate. So let's take a small data set where we have 2, 4, 4, 6, and 10. So for calculating mean, we just sum up all the values and divide it to the number of values. So if the data is not heavily skewed, mean can be used. For median, we just select the middle value by formula. If we have a sorted data set, a simpler one having definite values, then we just use the formula. If we have even number, then we use n by 2 data plus n by 2 plus 1 data at that position divided by 2. Here, this is how we get median value for the even number if the data set has even number of items. And for calculating the median value for odd number of data sets, we just do n divided by 2. Here we have 2, 4, 4, 6, 10. So we have 5 data sets. And actually n divided by 2 plus 1, that data is actually chosen as the median. Here 4 is chosen. It is used when the distribution is skewed or contains outliers. Mode gives us the most frequent value in the data set. So here it is very evident that the 4 occurs the most in the data set twice. So it will be chosen. It is used for categorical data to identify most common typical value. Multimodal values are even possible. Unimode, if it is unimodal, then one mode is present. Bimodal, then two modes are present. In multimodal, then more than two modes are present. Standard deviation is calculated by the square root of the sum of difference between each data set, each item in data set, and the mean divided by the total number of data set. And we calculate the square of the difference. So here you can see calculation is done in the most simplest way. And standard deviation is used to measure the spread when the mean is meaningful, sensitive to outliers, because here also we are using mean. Moving towards the next question, we have what is the difference between error and artifacts in data cleaning? Explaining any two imputation techniques. So errors are the information lost due to input mistakes, sensor fault, transmission error, or human entry. They are invalid and corrupted value. It cannot be recovered. While artifacts are the systematic distortions introduced by measurement process or pre-processing, like duplicated rows due to logging, rounding biases, sensor calibration bias. Artifacts may be consistent but not true values. Actually, it is systematic errors that occur that can be corrected if detected. Imputation means filling value in place of missing values in a table. So the two imputation techniques that we can use is the mean or median imputation, in which we replace the missing value of the column with the column mean. It is simple, fast, preserves data set size, but it is bias correlations. It can lead to bias correlation, underestimate variance. Use when missingness is small and data is fairly symmetric. Or when data is symmetric, then we use mean, and when data is skewed, then we use median. K nearest neighbor imputation. In this, for each missing value, we find the K nearest records using other features, and then we impute using mean of neighboring values, uses multivariate relationship and can preserve structure, and therefore it is used, but it is computationally expensive and sensitive to scaling and choice of k. The next question we have: explain any four common feature engineering techniques for continuous or categorical data. So here I have chosen to explain four common feature engineering technique for continuous data. And no, actually I am explaining both of. So for continuous data, we use scaling or normalization. So why scaling? Why we do scaling? Suppose we have columns having different kinds of data. First is salary and the second is age. For making right predictions, it there is no uniformity in data, which leads to bad results. So for making the data uniform and standardized, we use certain scaling and normalization methods. The first is standardization z-score, in which we subtract each item from its mean. Actually, we subtract the mean from each item and divide by standard deviation. It is useful for algorithms sensitive to scale, SVM, KNN, gradient descendant. Min-max scaling maps the value to 0 or 1 range. Suppose if we have different columns and all the columns contain values from 0 to 1, then it will be more easier for us to understand on what basis decision making is happening. In this, we preserve distribution shape, but it is sensitive to outliers. Binning discretization converts continuous values into categorical beans. If we have numerical data where we have to categorize the data into beans or group them into beans, then we use the method of binning. Suppose if 0 to 18 values in bin 1, 19 to 30 value is in bin 2. It can be done by fixed width bin or quantile bins. It helps capture non-linear patterns and reduces noise. Encoding of categorical value. One hot encoding. Why do we do encoding? So we do encoding because a certain ML algorithm cannot work on categorical data, and it works very efficient if the data is described in numerical format. So that is why the categories are encoded into vector form. In one hot encoding, we separate binary column for each category. In ordinal coding, we assign integer value to order categories, like we assign 1 to low, medium to 2, and then high to 3. But we can't do the same in case of fruits, otherwise it will lead to manipulated result. Target or mean encoding: replace the category with the mean of targeted variable. Feature interaction, polynomial features. It creates interaction terms such as x1 cross x2. It helps to capture hidden nonlinear relationship, especially linear models. Missing indicators. Add a binary column indicating whether a value is missing or not. It is useful when the pattern of missing value is informative of prediction. All these techniques are used for evaluating features in a form that can be more useful for us to understand as well as for the ML algorithms, and it helps to this it helps to get even better results. Moving towards the next question, we have distinguish between parametric versus non-parametric model and supervised versus unsupervised model. So what parametric model actually means? This is a model that already assumes a function form and shape, uh, but it leads to overfitting. It is though simple, fast, and it needs less data, but it leads to overfitting. And it is used in linear regression, logistic regression, naive Bayes with Gaussian assumption. Talking about non-parametric models, it doesn't have a fixed assumption about the function form. Its complexity grows with data. This model can model complex relationships. It requires more data and it can be a little slow. For example, KNN, decision tree, kernel, density estimation, Gaussian process. Moving towards the next one, which is supervised learning. It learns from mapping input X to target Y using label data. Here, the ML algorithm learns the relationship between input and output. It is used in regression and classification, and its key methods are linear regression, SVM, random forest neural networks. While unsupervised learning is discovering structure for unlabeled data. We are given data having inputs only, and we will have to understand what the relationship it maps and what could be the output. It is used, for example, it is used where clustering, dimensional reduction, or association rules come into picture. For example, customer segmentation, anomaly detection, feature learning. So all these are, so the first two were the kind of model, and these two are the model that learns in a different way. Moving toward the next question, we have question 5b, which is define accuracy, precision, recall. F1's going to illustrate their computation using a confusion matrix. So a confusion matrix is used to used for the evaluation of the outputs given by an ML algorithm, in which we have true positive, true negative, and false positive, false negative. We just map predicted positive and negative versus actual positive and negatives. So what is accuracy? Accuracy is about, among all the predictions made, how often the prediction was correct. So its formula, so is its formula, true positive plus true negative divided by true positive plus true negative plus fake false positive plus false negative. But it can be misleading if the classes are imbalanced. Talking about precision, it's about out of all predicted positive fraction that are truly positive, above about in about all predicted positive, the portion that was correctly predicted positive. Its formula is true positive divided by true positive plus false positive. It gives high precision means false alarms, less false alarms. Recall is also known as sensitivity or true positive rate. Here, it's about the actual positive fraction correctly identified. So it's true positive divided by true positive plus false negative. High recall means fewer missed positive cases, and missed positive cases can be expensive. F1 score, also known as the harmonic mean of precision and recall, is calculated by multiplying 2 to the product of precision and recall and then dividing precision plus recall. It is useful when the data set is imbalanced and a balance between precision and recall is needed. For example, here we are given an example where true positive is equal to 70, false positive is 10, false negative is 20, true negative is 900. So a total of it becomes 1000. Accuracy is 0.97, precision is 0.875, recall is 0.777, and F1 score is calculated to be 0.8235. So this is how we evaluate the performance of a model using all these parameters. We also use ROC curves, but here I have explained only these. Now I am ending this video right here. In the next video, I will be solving 4 questions that are left to be solved. I hope that all I explained was easy to understand, and thank you for listening to me with so much patience. Thank you so much.